Alrighty, so in this video, we are going to start introducing this idea of radicals of square roots, which you may be a little bit familiar with. First off, I want you to list the numbers that you see there. Perfect squares. These numbers in red are going to be super important to recognize, and because we're going to be seeing them a lot, not only in this class, but also in future classes. And remember, squaring is not saying like 3 squared is not 3 times 2. Squaring is multiplying a number by itself. So 3 squared is going to be 3 times 3, which gives me 9. So I'll give you a chance to write down all those numbers and start familiarizing yourselves with them. Okay? So, a radical expression is just that, an expression that contains a radical. And for what we're talking about in this class, that's going to be square roots. So, a radical expression is an expression that contains a square root. And there are a couple of rules. Inside that square root, underneath that square root, there cannot be a perfect square because we can simplify that because square root undoes squaring. So there can't be a perfect square under that because we can simplify that further. A square root cannot contain a fraction, and a square root cannot be in the denominator. And these last two, these are more important for your next future math class. Just wanted to introduce that here. That way you knew that that existed. Okay? So if I want to simplify the following radicals. Square root of 81, well, we know 81 is a perfect square. So if square root undoes the perfect square, square root of 81 is going to be 9. Square root of 16 is going to be 4. Okay? What about square root of 72, though? 72 is not a perfect square. Okay? So what we're going to do is we're going to break down 72 and try to expose the perfect squares that are within 72. And how we're going to do that is we can break down the numbers. So, for example, you see here in this rule, square root of a times b, we can break that up into the square root of a times the square root of b. So, for example, square root of 4 times 9. 4 times 9 is 36. So the square root of 36 is 6. Or, you see here, you break that up into the square root of 4 times the square root of 9, which is 2 times 3, which still gives you the same answer of 6. Okay, so we can break down these numbers. And the way we're going to do it is like a factor tree, which you've done in the past before. So like square root of 72, I can break down 72 into what? Well, I know 2 has to go into it because it's even. So square root of 2 and square root of 36. Okay, well, I can stop there because I know what the square root of 36 is. Square root of 36 is 6, which means 6 gets to come onto the outside. What's stuck underneath? There was a 2 that was stuck underneath. Okay? So if you can train your eye to try to find these perfect squares when you're breaking down the numbers, that's going to make your life a little bit easier. But sometimes that isn't possible. Okay? Sometimes you just got to break it down as much as you can. So that's what I'm going to do in the next problem, B. If there's any perfect squares, I'm going to ignore them for right now, just so that you can see what you need to do in case you don't notice the perfect squares. So, square root of 80. Square root of 80, I know 2 goes into it. 2 times 40. Okay? Square root of 40, I know 2 goes into that. 20 times. Square root of 20, I know 2 goes into that. 10 times. And 10, I know it can break down to the square root of 2 times the square root of 5. Now, I cannot break that down any further. So, what I want to do now is think, okay, this is square root of 2 times the 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 square root of 5. That's what I broke this down into. Okay? But you'll see that there's some repetition here. Square root of 2 and square root of 2. That's going to be the square root. If I multiply these together, that's the square root of 4. We know the square root of 4 is 2. Okay? Similarly here. These square roots of 2 get to buddy up, become square root of 4, which ultimately simplify to give me 2. But 5 doesn't have a buddy stuck underneath the radical. Square root of 5 doesn't have a buddy, so it's stuck underneath. So when I simplify this, 2 times 2 is 4. Square root of 5 is stuck underneath. Okay? These take a little bit of thinking, a little bit of logic puzzles, but you want to pair up what you can, and if it has a buddy, it gets to come outside. If it's left alone, then it's stuck inside. Okay? Another way we could have done square root of 80, looking for perfect squares, is we know, or we can try our calculator, we know 16 goes into 80. 16 times 5. Square root of 16 is 4. 5 is stuck underneath. So you see how if you can expose the perfect squares in these numbers, that's going to make your life a little bit easier. Okay? Let's look now at square root of 21. Square root of 21, what does that break down into? Well, square root of 3 times the square root of 7. Can you break down 3 or 7 anymore? No, because they're both prime. Can they buddy up and come outside? No, because they're different numbers. Therefore, all I can do is keep that as square root of 21. Square root of 21 does not break down anymore because there are no perfect squares hidden within square root of 21. Okay? And next we're looking at square root of 45. Well, square root of 45, I know 5 goes into it, and I know 9 goes into it. Well, 9 is a perfect square, but let's say we didn't see that. Let's say we broke down 9 some more into square root of 3 and square root of 3. Well, now we've broken down everything. Square root of 3, those get to buddy up because there's 2 of them, which means a 3 gets to come outside. A 5 does not have a buddy, and it's stuck inside. Okay? So that's how we want to look at these problems, is try to expose the perfect square. And if you can't expose the perfect square, try to match the buddies. Buddies get to come outside. Anything that's at the end of a stem, and what I mean by that is like the end, this is an end of a stem. Anything that's at the end of a stem that doesn't have a buddy has to stay underneath. Okay? So that is going to wrap up that one. And I'm going to do the same thing that we did in the last video. These you try nows, I'm going to have them in Schoology for you. Okay? And I want you to practice on those and let me know if you have any questions.